In this video, we will discuss about the flanged coupling. Okay, so flanged coupling is also one of the part of the torsion. Okay, in the previous videos, the number of videos we solved the problems and derived the different equations related to the torsion. Torsion equation we derived. Okay, so now this flanged coupling is one of the part of the torsion, and we will solve related to the problems on flanged coupling that we'll see here. Okay, first we'll see the diagram of the flanged coupling. What do you mean by flanged coupling? So here the coupling means here there are two shafts. Here if you see that this is one shaft, shaft 1, this is shaft 1 and this is shaft 2 here. One solid shaft, one more solid shaft, two shafts. If you want to connect these two shafts together, then we are using a coupling, the flanges. Two flanges are there. We need two flanges. Those two flanges form together a coupling. Okay, so it is called flanged coupling. Okay, so if you I'll see here, this is shaft 1 and shaft 2. Two shafts of, but the diameter is same. Almost the couplings are used to connect two shafts of the same diameter. So here D I written capital D. The shaft 1 capital D and shaft 2 also same capital D. If you want to connect these two shafts together, we are using a flanges. Here flange 1. This is flange 1. Whatever the green color is there, this is flange 1. And here the blue color is there, it is a flange 2. Okay. So this is the front view of the flanged coupling, and this is the side view. All it will be related to the circles. It will come here. Okay. So how we will connect? If you want to transfer the power from one shaft to another shaft, obviously these two shafts need to connect together with the help of the flanged coupling, and these flanges were connected with the help of the bolts. Or bolts and nuts or rivets. If you see the side view here, so this is one of the these are the bolts here. So total I draw that 8 bolts here. With the help of these 8 bolts, these two flanges are connected. Okay, so power is transmitted from shaft to the bolts, these bolts, and then from these bolts to one more shaft through this coupling. Okay, so we will read the problem here. We'll read the related the points here. The first point, as I said, flanged coupling used to connect two shafts. If you want to use the coupling, if you want to connect two shafts, we are using the flanged coupling. Flange 1, flange 2. So next point, the flange connected by bolts and nuts. As here flange 1, flange 2 is there. How they are connected? With the help of the bolts and nuts. Here bolts and nuts together, or rivets. Instead of bolts and nuts, you can use rivets also. Okay, with the help of these bolts and nuts, you can connect the shafts and flanges here. Okay. Next, torque transfer one shaft to another through bolts. See here, this is first shaft. See that this is one shaft, first shaft. To this we are connected to motor. If the main motor source, if you connected, this will become driver. Okay. To this, first when it will rotate, whatever the torque produced, this torque is transmitted first the bolts and nuts of the first flange. Then it will transfer to the next flange to the bolts and nuts. From there it will goes to the second shaft. Then this shaft will be rotated. Since these two are connected, this will be rotated here. What I mean, the torque is transmitted from one shaft to another shaft through bolts and nuts only. That is very, very important. The next point, shafts connection through keys and keyways. Okay. Now this is one shaft, this is one more shaft. How you are connected? These are the flanges are there. Here you are connected with bolts and nuts. Also here you need to create the keyways. First, it means in the manufacturing they are doing the keyways here. Okay, keyways, as if you see here, this is keyways. In this shaft, and in this flange, they will create a keyways. they'll produce a keyway. Okay, so after producing a keyway, they place the key. They place the key here, so that these two shafts will be aligned together, balancing. For balancing purpose, these two shafts will be made with the keys and keyways. If there are no keyways and keys you will not produce, then these may be in eccentric. There may be chance of the line of the whatever the axis, it will be changes here. Okay, that is the thing. Shafts are connected through keys and keyways. Here you are looking, this is keyway, and inside the keyway you are placing the key, so that these two flanges and shafts sits together very tightly. Bolts also required, keys and keyways also required. Next point, bolts arrangement through circle called PCD. How the bolts are placed here? Here, if this is the front view and this is the side view. If you place this here, and from here to here, this whatever the circle you are producing, that circle is called pitch circle diameter, PCD. PCD. In this hole, in this circle, in this diameter, you are making a hole and you are placing a bolts and nuts. Bolts and nuts. This circle is called, this diameter is called pitch circle diameter. Pitch circle diameter, and it is denoted by capital D star. Okay, so this is required while deriving the equation. The pitch circle diameter PCD is called D star, capital D star. Shaft diameter is called capital D, capital D. And bolt diameter, whatever the bolts, number of bolts we are drilling there and placing the bolts, that diameter is called small d. Okay, one is small d, bolt diameter, shaft diameter is capital diameter, and the pitch circle diameter is D star. D star. Okay, so next point, bolts subjected to shear stress. These bolts are subjected to shear stress when torque transmitted from one shaft to another shaft. Okay, listen here, how the power transmitted. As I said, the torque transmitted from this, the driver shaft to driven shaft through the bolts. It means when the shear stress and torque is developed on this driver shaft, this is transferred to the bolts. The number of bolts here 8 are there. You can place a number of drills, the bolts here. It is transferred to the bolts. Then from the bolts it is transferred to one more shaft here. Okay, so bolts and nuts are very important when design, for the design criteria. These are all the points here. Now we will derive the how the power is transmitted from this shaft to this shaft, one more shaft, with the help of the bolts here. Okay, I will write the data here, then we will derive the equation. So I will write the notation first. What is the D here? Let capital D equal to diameter of the shaft. Both shafts are same diameter. Okay, diameter of shafts. Shafts 1 and shaft 2. Shaft 1 and shaft 2. Okay. Next, what is the small d? Small d is diameter of bolts. That is diameter of bolts. Okay. Next, one more. The D star, capital D star is, what is that? It is pitch circle diameter, PCD. It is called pitch circle diameter. On that only you will drill a hole and you will place a n number of bolts here. Okay, that is PCD. PCD inside the bracket, pitch circle diameter. Pitch circle diameter. Okay. Next, tau. Tau equal to, what is the normal notation previously we used in video, so a number of videos here. Tau is shear stress, maximum shear stress of the shaft, this shaft. Okay, so maximum shear stress of shaft. Okay, because we need to start from this shaft, because motor is connected to this and it will start with the shear stress and the torque from this shaft. Okay, next, Q equal to shear stress developed in the bolts, this stress transferred, that is shear stress in the bolts. Okay. Next, n equal to number of bolts. number of bolts. Are you get the points here? It means you have one capital D shaft diameter, one small d bolt diameter, and capital D star, it is pitch circle diameter, and tau is shear stress developed in the shaft, Q is shear stress developed in the bolt, and N equal to number of bolts. How many number of bolts? Remember, the concept is only you need to transfer the torque or shear stress from one shaft to another shaft through bolts. So here bolts also comes into picture, bolts, shear stress, and the number of bolts, and the shaft the diameter also it will comes into picture. So I will erase this one and we will derive the equation for the flange coupling here. Okay. We will consider a single bolt first. Single bolt. So maximum load transmitted by one bolt. That is maximum load transmitted by one bolt, by single bolt. Okay, single bolt equal to, I'll write in terms of shear stress. What is the shear stress of bolt here? Q, right? Q is shear stress in the bolt. This is Newton per mm square, right? Newton per mm square shear stress. If I want a load, multiply by area, right? Into area of the bolt. Area of bolt, right? This is mm square. This cancels, you will get the maximum load transmitted. Okay. So this will be equal to Q into, what is the area of bolt? Diameter of the bolt is d, small d. So area is pi d square by 4, right? So area is pi into d square divided by 4. Will you agree here? Q is shear stress on the bolt into area of the bolt. Then you will get the load transmitted. So area of the bolt is pi into d square by 4. D is the diameter of the bolt. Okay. Next, once if you find the maximum load, what will comes into picture? Torque. Torque are the twisting moment. Okay. Twisting moment is related to load. Load into distance, right? Next, the torque resisted, because it should be it is resisted. You are transferring the torque from the shaft, driver shaft, to the bolts. So bolt should resist the torque, right? So now I am writing torque resisted by single bolt. By single bolt equal to the maximum load transmitted by bolt into load into distance. Distance from where to where? It is from center, here from center to the pitch circle diameter, because in the pitch you have here pitch circle diameter, right? In the previous the video I raised, in the figure I raised, this is pitch circle diameter. Here the bolts are there, right? The number of bolts. So from here to here, what is the distance? Pitch circle diameter divided by 2, right? Therefore pitch circle diameter divided by 2. Distance from center to pitch circle diameter. Okay. So I will write here Q into pi d square by 4 into how much is the pitch circle diameter? Pitch circle diameter is d star. D star divided by 2. D star divided by 2 here. So this will be equal to Q into pi d square divided by 8 into d star. This is torque transmitted by the single bolt. Okay. So if I want the n number of bolts, how much is the torque transmitted by n number of bolts? Therefore torque transmitted by n number of bolts, n bolts. equal to, simply multiply by n here, right? That is n into q into pi d square divided by 8 into d star. Okay, this one is equation A. Call it as equation number A. You have calculated torque transmitted by single bolt, then torque transmitted by torque resisted by. This is torque resisted by, because it will be resisted by n bolts, n number of bolts. Now what is the next one? I need to calculate torque transmitted by the shaft. This is the driver shaft, right? This is the driver shaft here, and from this here you are transferring the bolts. Okay, here the couplings are there, the flanges. I wrote the equation for the torque transmitted by n number of bolts resisted. Now I'll write what is the torque transmitted by the driver shaft. Okay, next one is torque transmitted by shaft, right? Transmitted by shaft. This will be equal to, how much is the torque transmitted by this is a solid shaft. We already wrote the equation in the previous video so many times while solving the problem. For solid shaft, what is the torque equation? Torque equation is pi by 16, it is a solid. Pi by 16 into tau is maximum shear stress, into d square, into d cube, right? This is d cube. Tau is maximum shear stress here generated, d is the diameter of this shaft. Okay, so now call it as equation number B. Now can I equate equation A and B? Because we can equate, because the torque transmitted by this shaft is equal to torque resisted by the n number of bolts. When it will be resisting, then only it will transfer to other shaft. Okay, so therefore from A and B, torque transmitted by shaft, torque transmitted by shaft equal to, what is it equal to? Torque resisted by n number of bolts, n number of bolts, right? Okay, how much is torque transmitted by the shaft? Pi by 16 tau into d cube equal to, what is the torque resisted? Just before I erase here, what is that the equation here? That is torque resisted by the n number of bolts is n into q pi d square by 8, right, into d star. Okay, so equate these two from this equation. This is the final equation in the flange. So depending upon the unknown data, you need to calculate what are the unknown data. Suppose for example, calculate the number of bolts required in the flange. Here n is there, you can calculate. So calculate shear stress developed in the bolt, you can calculate this one. Calculate the pitch circle diameter of the bolts, you can calculate this pitch circle diameter. What is the diameter of the bolt, you can calculate. And what is the diameter of the shaft and shear stress. Here so many unknown data are there. Depending upon the problem data what is given, you can use and you can find out the unknown data. So with the help of above equation, we can find unknown data. We can find the unknown data. Say for example, number of bolts. Okay, that is n, you can calculate here. Okay, this is the derivation for the shaft coupling shaft here. In the next video we'll solve the problem related to this derivation here. Okay.